In this lesson, you will learn how to work with the exponent properties. There are 6 exponent properties we will learn in this lesson. I number them 1 through 6, but it's not necessarily property number 1. It's just the first one that I list. So let's look at the properties. The first one is a to the 0 equals 1. The second property is a to the m times a to the n equals a to the m plus n. So if you have exponents, or if you have powers that are multiplied together, notice the a's are the same, so their bases would have to be the same. You're able to add the exponent of those powers. The third property is a to the m to the n. That will be a to the m times n. To remember this one, if you have a power to a power multiply, I stress those p's to help you remember the property. Power to power multiply. Property number 4, this one has an a and a b, so different bases, all raised to an exponent m. That just means that the a gets the exponent power, the b gets the exponent power. So it's just saying if you have things in here multiplied together, each thing that is in that parentheses, each factor in that parentheses gets the exponent. Property number 5, a to the m divided by a to the n. So again, noticing the common bases here with our powers. You have to have the same basis. Your exponents in this property, we can take and subtract in order to simplify. Property 6 will have a and b, so different bases divided, all raised to the m power. So just as property 4 says, if you have things multiplied together, each thing can get the exponent. It works the same with division. If each thing is divided raised to a power, the a can get the exponent and the b can get the exponent. There are more exponent properties you'll learn in later lessons or even later classes. But as of right now, we will just cover these 6 properties. In order to know that you have simplified your problem completely, there are some rules. One rule is that there are no powers of powers. So in order to have no powers of powers, we have the exponent property 3 to take care of that. If we have a power raised to a power, we multiply. So that can take care of simplifying that rule. Another rule is that each base appears only once. So when each base is only going to appear once, we can see that we have some properties to help take care of that. Property 2, if we have multiple bases of the same type, we can combine them if they're being multiplied by adding their exponents. Or the same deal here with property 5, if we have the same base that's being divided here with their powers, we can subtract their exponents again to simplify. So each base only appearing once, we have some properties to help take care of that. Property 3, and really this is a general math rule, but it works with our properties also, is that all fractions are in simplest forms. All fractions in simplest forms. So, for example, if you had a fraction that said 4 over 12, you would not leave a fraction as 4 over 12. You would need to reduce that. 4 goes into itself once, 12 4 goes into 12 3 times. So just like a general math rule, you would need to simplify all your fractions. That's the same with our exponent properties. And of course, we've got properties to help handle that. We couldn't leave this fraction raised to a power. We would need to apply that exponent on each of those bases. And rule number 4 is that there are no negative exponents. So I won't really hold you accountable to the properties for the negative exponents, just so that you'll know what they look like in later lessons or later coursework. In order to take care of that rule, there are 3 more properties. So property number 7. There's a property that says if I have a negative exponent, so maybe a to the negative n, I can make that become 1 over a to the positive n. I can flip that negative exponent to the denominator and make it a positive exponent. Of course, putting 1 in the numerator because there's an understood 1 here as the denominator. Property 8 would work kind of in the reverse of that. If I have 1 over a to the negative n, if my negative exponent starts here with my fraction, then that would become a to the positive n. Again, just kind of flipping that to the numerator. Being careful that it doesn't always mean that if there's a number in the top, so in this case, yes, there is a 1 in the top, it doesn't necessarily flip that whole number. If this was a 4, so if it would have been a 4 over a to the negative n, we would still leave the 4 because it does not have the negative exponent. Only the a has the negative exponent. And the a to the positive n would come up to the top. And then the final one that has a negative exponent is if the whole fraction a over b is raised to the negative exponent, we can flip that fraction, make it b over a to make that become positive. Then of course we have to use that property 6 and say that the b gets the exponent and the a gets the exponent. But as of right now, you will have no work using these negative exponents. I wanted you to be familiar with them for when they come up later or even in other classes, other coursework. So let's look at some examples for our work. So example number 1, we have t to the 0. Well, referring back to our properties, anything to the 0 power equals 1. You could always check this in your calculator. Pick your favorite number and type it in. So 14 raised to the 0 will equal 1. Negative 7 raised to the 0 equals 1. So this is a property you could always check with the calculator and making sure that you're thinking of it correctly. Raise a number to a 0 power and it should give you a value of 1. Example number 2, we're going to do 3 to the 3rd power times 3 to the 6th power. Now obviously, since there's all numerical values here, we could punch this in the calculator and get the answer. However, that's not what our goal is. We want to actually use our properties. So noticing that we're multiplying our powers, that would mean we add our exponents. So 3 plus 6 gives us to the 9th. I'm fine with you stopping there. Once you show that work and get that to 3 to the 9th, you can then punch it in the calculator to see the value. But my main goal is using exponent properties, so I will be looking for this as your answer in your work. Example number 3. This time we have y to the 5th raised to the 8th. That is a power to power, so we're going to multiply. So 5 times 8 gives us 40. So y to the 40th. Power to power, always multiply. Example number 4, we have m, n, and all of that is raised to the 3rd. So in these parentheses, if it's multiplied together, in that parentheses, if we have multiplication, the m can get the 3rd power, the n can get the 3rd power, and if there's another letter, that could also get raised to the 3rd power. So in this case, m gets the 3rd power, n gets the third power in order to be simplified. For number 5, we have 8 to the 7th over 8 to the 4th. Again, this is one, since it's all numeric values, you could actually check it with the calculator, but be sure you use your exponent properties first. 8 to the 7th and 8 to the 4th, they have the same bases, so we're going to subtract their exponents. So 8 to the 7 minus 4. 7 take away 4 will give us 3. Something I see often here is students want to take the 8 and actually divide it. This is not just 8 divided by 8. You cannot divide 8 divided by 8 and make this 1. So I should never see 1 to the third power. Students try to divide the 8 and subtract the exponents, and that would be an incorrect answer. These do not have the same value. Only subtract the exponent when using that property. Example number 6. Here we have x over y, and all of that is raised to the 5th power. So very similar to property number 4, if you have multiplication, each thing can get the exponent. You can apply the exponent. And if you have division, each thing can get the exponent. So the x to the 5th power and the y to the 5th power. Let me go ahead and stop here and mention a property that's not a property, or let me just note something that is not a property I often see students try to do. Example 4 and example 6 work because we have a property. If you have multiplication or division, you can apply that exponent to each thing. It does not work in the case, so let's just write not a property. This one is not a property when we take and we have maybe a plus b all raised to exponent power. I often see students trying to take that exponent and apply it to each the a and the b, and that does not work. So it does not equal, put a huge big does not equal a to the m plus b to the m. And the same would be true if that was a minus sign. If it said a minus b all raised to the m power, again, you could not apply that exponent for each of those bases. Oftentimes where I see this happening is like 4x plus 5, all of that is squared. Students try to, and it does not equal, they try to take 4x and square it and take the 5 and square it. But know that that is not something that can happen. We will learn in later lessons how to handle something like this when it is squared with a plus or minus sign. At this time, though, we're going to just work with these 6 properties. Know that it does work with multiplication and division. You can apply that exponent, but not with addition and subtraction. For example 7 through 12, you may copy these problems and pause the video and come back and check your answers. So let's check your answers on 7 through 12. 2 to the 4th squared is a power to power, so we will multiply. So 4 times 2 is 8, so it'll be 2 to the 8th. Because that's all numerical values, you could check that in your calculator. So let's look at that in our calculator. So in our calculator, let me zoom, there we go. We want to put 2 to the 4th, so there's parentheses here just above the 8, so parentheses 2. If you're trying to raise something to a power that's not squared, there's a caret key under the clear button, so raise to the 4th. You'll need an arrow over because notice how in your calculator the cursor is still up in the exponent, so arrow out and close that parentheses and then raise it to the 2nd power. When you raise something to a 2nd power, you could also use the x squared button. I tend to stick with the caret key because I'm just used to using that always for my exponent, but there is one for just squaring. So 2 to the 4th squared gives me 256. It should equal what 2 raised to the 8th if I've done my property correctly, and it does check out. So you can see that you're thinking correctly on your exponent properties before moving on. Let's take a look at our next one. B to the 15th, B to the 7th, you would subtract 15 and 7. So 15 take away 7 gives us B to the 8th. Even though in this one we don't have a numerical value, we can make up a number for B. If you want B to be 10, so put 10 raised to the 15th. We can divide just using the division button, or even do alpha y equals. So let me do alpha y equals. Actually, I think it works there. Alpha y equals, and choose that first option, and went ahead and put that 10 to the 15th in the top. And so now we want 10 raised to the 7th. We're just choosing a number for B. It can be any of your favorite numbers. I tend not to use zeros and ones if you're replacing a variable, because they have special rules in math, 0 and 1. You could have even used 2 or 5. So let's see if it equals what 10 raised to the 8th power would have been. That way we know that we've used our property correctly. We just substituted in a value for B. X to the 4th times x to the 3rd. We add those exponents. If you imagine writing out these 4 and writing out those 3, there would be 7 altogether. Add 4 and 3 together. Again, you could go to the calculator and check. You could substitute some value for x and raise it to the 4th power times, again, the same value for x, raise it to the 3rd power, and check that with that number raised to the 7th power. So you could always substitute something in for x and check with your calculator that you're getting your properties correct. For number 10, we have a 4m all raised to the 3rd power, so the 4 will get raised to the 3rd, and the m gets raised to the 3rd. For number 11, anything raised to the 0 power equals 1. That piece equals 1. If this was within a whole problem, then again, just that piece would equal 1. It wouldn't necessarily mean the whole problem would equal 1. So let me show you what I mean. If we have negative 5 raised to the 0 power times 7 over, I don't know, 2b, just making something out. Only this piece here that is raised to the 0 power would equal 1. Some people want to make the whole problem equal 1, and it does not work that way. Just that piece that is to the 0 power would equal 1. So that would mean this would be 7 over 2b, because times 1 would just make a 7 in the numerator. And for our example 12, we have 3 to the 2nd power and 4 to the 2nd power. Of course, leaving it as a division problem, the division does not go away. It's just each thing gets that 2nd power when we are simplifying. These examples just show how each property works on its own. It is possible to use more than one property within a problem to simplify. So just look back at your properties that you've listed from the start and just take it one step at a time, applying one property and then moving on to the next one.